Imagine standing on a vast sandy landscape. The air is warm and dry. All around you, strange rock formations rise towards the sky. You look up at the horizon. The day is ending. But something is different here. Something truly extraordinary is about to happen. Not one, but two suns are sinking below the distant hills. They cast long, overlapping shadows across the desert floor. This is a scene millions of people around the world know and love. It's the iconic double sunset from the planet Tatooine in Star Wars. This image has captured our imaginations for decades. It paints a picture of a universe far more diverse than our own. The idea of a planet orbiting two stars feels like pure fantasy. For a long time, that's exactly what it was. Scientists thought such a system would be too chaotic. A planet caught between the gravitational pull of two stars would surely be torn apart. Or perhaps it would be flung out into the cold, empty darkness of interstellar space. But what if this idea wasn't just science fiction? What if, scattered across our galaxy, there are real planets that call two stars their own? The universe is often more incredible than we dare to dream. The story of these twin sun worlds is not just a tale from a galaxy far, far away. It is a real story of scientific discovery. It is a quest to find planets that exist in the most unlikely of places. The journey to find these real-life Tatooines is a testament to human curiosity. It shows our deep desire to look up at the night sky and ask, what else is out there? How do you find a planet you cannot see, especially one that is orbiting two stars, hundreds or even thousands of light years away? It is one of the greatest challenges in modern astronomy. To find these hidden worlds, astronomers had to become detectives. In a circumbinary system, the planet can pass in front of one star, then the other. The timing of these transits becomes much more irregular. It creates a unique and complicated pattern of light changes. Unraveling this complex signal is the key to finding a circumbinary planet. It was missions like NASA's Kepler Space Telescope that made this possible. For 4 years, the telescope floated in space, monitoring the brightness of more than 150,000 stars simultaneously. As scientists sifted through the light curves, they sometimes found patterns that made no sense for a single star. But some scientists wondered if they were seeing something else. Could this be the signature of a planet orbiting not one but two stars? This was the moment the hunt for real Tatooines truly began. In 2011, the search paid off in the most spectacular way. A team of scientists announced the discovery of Kepler-16b. It was the first planet to be unambiguously discovered using the transit method as it passed in front of two stars. Kepler-16b itself is not much like the desert world of Tatooine. It is a cold gas giant, roughly the size of Saturn. While you could witness a stunning double sunset from the top of its clouds, it is not a place where life as we know it could survive. But the significance of Kepler-16b was not about its potential for life. It was about its very existence. It proved that circumbinary planets are real. To truly understand a world with two suns, we must first look at the stars themselves. More than half of all the stars in our Milky Way galaxy are not alone. They are locked in a gravitational embrace with one or more stellar companions. These stars orbit each other in a constant, beautiful, and sometimes complex cosmic dance that can last for billions of years. They circle a shared point in space called the barycenter, or the center of mass. The variety is immense. These systems can be made up of two stars similar to our Sun, or they could be a mix of different types. This stellar partnership creates a dynamic and ever-changing environment. The existence of a circumbinary planet depends on a delicate balance. Get too close to the central pair of stars, and the planet enters a zone of chaos. The separate gravitational pulls of the two stars would become overwhelming. Astronomers call the safe region the zone of stability. A planet must orbit beyond this critical radius to survive. The planet must effectively be far enough away that the binary stars act as a single gravitational source. This concept creates a fascinating puzzle for planet formation. The gravitational forces of the two stars would clear out the inner part of the disk, carving out the very region where planets are thought to form most easily. This suggests that these planets cannot have formed where we see them now. They must have been born somewhere else. One leading idea is that they formed much further out in the disk, then migrated inwards over millions of years. The journey would have been perilous. They need a way to stop their inward journey just before they fall over the gravitational cliff. Remarkably, this is exactly what we seem to observe. Many circumbinary planets orbit just outside this zone of chaos. They are parked right at the edge of stability, as close as they can possibly get to their twin suns without being destroyed. Imagine waking up on a planet orbiting two stars. What would you see? From the surface, these two suns would never stray far from each other in the sky. They would rise together, travel across the celestial dome as a pair, and set together. The character of your daylight would be unique. Shadows would have a soft, fuzzy edge, as light from one star filled in the shadow cast by the other. At certain times, you might even see two distinct shadows for every object. The cycle of day and night would be far more intricate than the simple on-off switch we experience on Earth. You could have days where one sun sets just as the other is rising, creating a world with no true night at all. The climate and weather on a circumbinary planet would be a direct consequence of the complex energy it receives from its two suns. Most known circumbinary planets have eccentric orbits, creating dramatic system-wide temperature swings. As the planet swings in towards its suns, it would enter a supersummer, receiving a blast of intense heat and light. Then, as it swings back out, it would plunge into a deep, frigid superwinter. This constant fluctuation would drive powerful and chaotic weather systems. Storms could be far larger and longer lasting than any hurricane on Earth. Living on such a world would mean being subject to a climate system of immense power and complexity. For millions of people, Tatooine conjures up a rugged desert planet. But when science caught up with fiction, the reality turned out to be more complex. The first confirmed Tatooine was a cold gas giant with no solid surface to stand on. Most circumbinary planets we've discovered are large, gaseous worlds. This is partly due to a detection bias. Bigger planets are easier to find. So while we've mostly found gas giants, it doesn't mean smaller terrestrial Tatooines aren't out there. To date, Kepler has been responsible for the discovery of over a dozen confirmed circumbinary planets. Each one is a unique natural experiment, pushing the boundaries of what we thought was possible. Our search for real Tatooines has only just begun. The future of this search lies with a new generation of more powerful telescopes. Missions like NASA's James Webb Space Telescope are already giving us an unprecedented new view of the cosmos. With its incredible sensitivity, Webb can study the atmospheres of exoplanets in remarkable detail, searching for the chemical signatures of water, methane, and other molecules that could hint at the presence of life. Looking further ahead, projects like the Habitable Worlds Observatory are being designed with the specific goal of finding and imaging Earth-like planets around other stars. The dream is to one day capture a direct image of a circumbinary planet, not just a dip in light, but a faint speck of light, a pale blue dot orbiting its two suns. This would be a truly profound moment in human history. The search will be aided by combining different detection methods. Each new planet we find adds another data point to our models, helping us refine our understanding of how they form and evolve. The next decade promises to be a golden age for the study of these extraordinary worlds, a time when many more members of the twin sun family will be welcomed into our catalogues. The story of circumbinary planets is more than just a tale of astronomy and physics. It's a story about curiosity, imagination, and our place in the universe. It reminds us that the cosmos is far stranger, more complex, and more wonderful than we can possibly imagine. It is a testament to the power of the human spirit to ask big questions and to relentlessly seek out the answers, no matter how difficult they are to find. The quest is driven by the same sense of adventure that fuels our greatest fictional tales. So the next time you look up at the night sky, remember the story of these twin sun worlds. Remember that among those countless points of light, there are systems more alien and more spectacular than we ever dreamed. There are planets dancing to the rhythm of two stars, survivors of cosmic chaos waiting to be discovered. The universe is full of such wonders, and our adventure is just getting started. The search continues, fueled by the simple, powerful, and deeply human desire to know what else is out there in the vast and beautiful darkness.